So now starting with our Coleridge law states that the equivalent conductance at an infinite dilution of an electrolyte is equal to the algebraic sum of equivalent conductances or mobility of anion and cation of the electrolyte at infinite dilution. Okay, so it will be like the equivalent conductivity, the total conductivity of any particular electrolyte will be the sum of all those equivalent conductances of the anions and the cations of that electrolyte at infinite dilution. And pretty simple are the numericals that came for these, like you have to only add or subtract. Okay, so it is having an application, a very major application. It is having that degree of ionization of weak electrolyte is given by lambda c upon lambda naught, where lambda c is the equivalent conductivity at any given concentration and lambda naught is limiting equivalent conductivity, right? And also we had studied in equilibrium chapter that the dissociation constant of weak electrolyte is given by c alpha square upon 1 minus alpha. Okay, so here alpha, that is the dissociation constant, right? That can also be written as lambda c upon lambda naught. So therefore Ka, that is the dissociation constant of the weak electrolyte, can also be given by c lambda c upon lambda naught whole square divided by 1 minus lambda c upon lambda naught. And here it is over with our electrolytic cell or electrolysis. And now let us come to our batteries and cells. See, primary cells are the electrochemical cells, which is a source of electrical energy. Pretty obvious, electrochemical cell which must be the source of electrical energy without being previously charged. This is the most important point. Like, it cannot be charged again and again, it is not rechargeable, and the electrode reactions cannot be reversed. Okay, for example, dry cell, that is Llanche cell, and mercury cell. Okay, so all these substances which are used should be either pure solid or either pure liquid. Okay, and E cell is always constant. Coming to secondary cell, so this is a brief introduction, right? Secondary cell, the electrical energy from the external source is first converted into chemical energy, and then the source is removed and cell is made to operate in the reverse direction. Okay, means there is a need of external source so that the electrical energy can be converted into chemical energy, and then when the source is removed, the chemical energy gets started to form electrical energy, right? Act like electrochemical cell, right? So the secondary cells are rechargeable and can be used again and again because electrical energy is provided by an external source, right? And the moment external source is taken away, chemical energy starts producing electrical energy. Okay, so examples are lead storage batteries and those which are used in automobiles, and lithium ion battery and so on. Okay, so if we study about nickel cadmium battery and lead storage battery, we will be concluding very precisely the anode reactions and the cathode reactions taking place. Okay, so in nickel cadmium battery, as the name suggests, cadmium will act as a anode and cathode will be nickel oxide. Okay, so remember the electrochemical series, the trick zebra crossing have few code color, then after that was nickel antimony and silver, right? So for what was this for? This was for maintaining or attaining the last memory that cathode will be an anode, because cadmium will be an anode. Why so? Because it is more electropositive than compared to nickel, and cathode can easily displace nickel. Okay, because nickel is less electropositive as compared to cadmium. So cathode will be nickel oxide and anode will be cadmium solid. Okay, and electrolyte will be KOH, potassium hydroxide. Okay, so Very obvious, anode will be oxidation, right? So Cd will get converted into CdOH2, okay, plus giving out 2 electrons, and when reacted with 2 moles of OH negative, right? And now for NiO2, the cathode, if 2 electrons are given to this in the presence of H2O, NiOH2 is going to form, leaving 2 moles of OH negative. Therefore, the entire reaction that happens in a nickel cadmium battery will be cadmium solid plus nickel oxide solid plus water liquid, will be giving cadmium hydroxide solid plus nickel hydroxide solid. Simple as that. So nickel oxide will be cathode, cadmium will be anode, right? So at anode oxidation will take place, and cathode reduction will take place. The total reaction will be cadmium changing to cadmium hydroxide and lithium oxide changing to lithium hydroxide in the presence of water, and electrolyte was KOH. Pretty simple, 3 to 4 points to learn. Okay, then coming to lead storage battery. Lead storage battery, the most important secondary cell is the lead storage battery. Why so? Because these are used in automobiles and inverters. Okay, then it contains lead as the name suggests, and lead dioxide. Okay, so lead and lead dioxide will be anode and cathode respectively, and the electrolyte will be 38% of solution of sulfuric acid. Okay, so in nickel cadmium battery, nickel oxide was cathode, cadmium was anode. In lead storage battery, lead oxide is cathode and lead is anode. There the electrolyte was KOH, and here the electrolyte is 38% solution of sulfuric acid. The cell reaction will take place as at anode, Pb solid in the presence of SO4 2 negative ion will form lead sulfate, leaving out 2 electrons, while at cathode, lead oxide with SO4 2 negative
Till
will
then,
be
bye bye.
giving us lead sulfate plus 2H2O, when 4H positive and 2 electrons were also provided. So the overall reaction will be that lead and lead oxide in the presence of H2SO4 will be giving us 2 moles of lead sulfate and water. Okay, so this can also be reversed by charging the battery. So this was all for this particular audio, and we will be continuing from fuel cell, then primary cell, that is Lanche cell, and then corrosion, and then our chapter will be end. Till then, stay tuned.